So here we're given 1 sig dig, so you put 1 sig dig after the decimal place. Okay. For the next one, we have 2 sig digs. So when you're reading the sig digs, it's sig digs as normal, but when you're giving the answer, so for the hydronium ion concentration, it's same sig digs, but then for the actual pH or pOH, it only counts for after the decimal place. Okay, try putting the next one in. So there's 3 sig digs in this one, so you put it to 3 decimal places. And then this one is to 2 sig digs, so you put it to 2 decimal places. Okay. So let's do another example. So 6.30 grams of nitric acid is dissolved in 750 mils of water. What is the pH? So we have to do a couple things here. We need to remember stuff from our solutions chapter to do this. So what do we know about pH? Okay, what do we know about pH? What's its formula to find pH?
Negative log.
Okay, negative log of my hydronium ion concentration. How do I find hydronium ion concentration?
You could use your, I'll put that in before you can use C. That is N over V.
Okay, so I need to think about concentration equals N over V, but think about this. This is an ion, okay? This is the acid. So what you need to think is you need to ionize the acid. You need a formula or a chemical equation where you have H3O plus first. So this question is combining 3 different lessons into one. So first you need to go HNO3 and you need to ionize it. Oh, I should have added it to water. Silly. So it needed to be ionized first because you can't just assume that the concentration of the acid is the concentration of the hydronium ion. Because if I would have had, say, an acid like H2SO4, okay, that changes my balancing, right? So anyways, I won't go into that. But what you need to think now is this is your given information, this is your given, and this is your wanted. Okay, remember that back to that lesson on solutions, wanted over given? Okay, so see how this is tying in everything from solutions. So you write your information you know under given. So you're given that you have 6.3 grams of the, the nitric acid, but solid before it's dissolved. You know your molar mass because you can find it with your periodic table. You're told the volume. So now you can go, as Matthew, you suggested, your C equals N over V. You have to find your N first, though. So your N is equal to little m over big M. So your moles, or your N, is 0.0999p. So now that we have our N, now we can find C. C equals N over V. So your 0.099, etc., divided by 0.75 liters. So the concentration of our acid is 0.13 moles per liter. Now, this is not so bad because, what is this? Is this a strong acid? Help me out. Nitric acid? Yes. It's one of the 6 of the strong acids. So that means it ionizes 100%. Okay? If it didn't, we would say it only ionized 50% or whatever. We don't know. So this, though, we can say it all goes over. So now we want to find the concentration of our hydronium ion. So that's times by your wanted over given, which is just 1 to 1. So that's easy. Or it's simple, not easy. So we get 0.133 moles per liter. I hated when teachers said things were easy, because it was like, what if I found it difficult? Now are you calling me stupid? Right? So I'd say it's, simple, not easy. Simple things can still be hard. I hate it when people say things are easy. Because what if it's not easy for everyone? Okay. Anyways, so now you're at the step where now you can find the pH, which is very exciting because you've done several calculations. Oh, this should say H3O. Bad. Log of H3O plus. Oh, it's not working. Okay. Well, you got what I meant, right? Change that to H3O plus. Right here. H3O plus. So now you should get a pH of 0.875, which, think about that. This is nitric acid. It's one of your strongest acids on your list. So it should have a very small pH, right? Because on your pH scale, to the left side of the pH scale is stronger, right? So that makes sense. It seems logical. Awesome. So now, go to lesson 4, and you can do part 1 questions. Okay? Do part 1 questions now. And we will figure out how to use your thing.